Hello everyone, thank you for watching my video today on sigma notation or summation notation. Sigma notation is a more concise way to express the sum of k terms of a sequence. For any sequence, the sum of the first k terms is denoted as this. Okay, so we've been talking about sequences, and now we're going to start talking about series. And a series is just a sum of a sequence. Okay, and this is how we write it. Sigma is this E-looking letter. It's a Greek letter, sigma. The explicit formula that we've been working on a lot here goes here. This is what you put in the explicit formula to get the first term back. This is what you put in to get the last term back. Let's take a look at an example here, right? Each using sigma notation. All right, so we're going to go sigma. Always write the nth term next. So the nth term is the explicit formula. So you can just look at this and know what the nth term would be, or you can, if it's arithmetic or geometric, you can use what we've learned recently to write the explicit formulas for those. This one is actually arithmetic. So a sub n would be 2 plus n minus 1 times 2, which is 2 plus 2n minus 2, or just 2n. Okay, so this is going to be 2n. So what do we put in there to get the first term? That would just be 1, n equals 1. What do we put in to get the last term? If you don't know it by looking at it, you can always write this equation out, 2n equals 30, and that would give you 15. But for this one, you probably knew that if you put 15 in here, you get 30 back. So there is our summation notation for this first problem. Second one, so this one here is geometric. I can tell it's geometric. So sigma, my geometric formula for this one here is going to be the first term times r to the n minus 1. So my equation is just going to, my nth term is just going to be 1/3 to the n minus 1. So what I put in there to get 1, I would put n equals 1 in there. And this one goes on forever. So that means we're just going to put an infinity up there. C, use sigma notation to write a summation for this. Assume 1/4 is the first term in the sequence, and n equals 1 is a lower limit. All right. So for this one, we're going to have to look and see the numerator and the denominator are different than each other. So the denominator is just powers of 2. So it's just going to be 2 to the n plus 1. Okay, how do I know that? If you put 1 in here, you get 2 squared. If you put 2 in here, you get 2 cubed. 2 to the 4th, 2 to the 5th. Or you could also do this, since we know it's geometric. Oops, sorry about that. Since we know it's geometric, you can write our geometric rule out. Our first term would be 4 times 2 to the n minus 1. So you can also replace it with that. I would accept either for this problem. All right, the numerator isn't... I should leave that there. The numerator isn't geometric or arithmetic, but this one is actually increased. Let's see, it's increasing by 2, and then by 4, and then by 8, and then by 16. Okay, so this one, in the numerator, it's just the powers of 2, but then we subtract 1. So this would be 2 to the first minus 1, 2 to the second minus 1, 2 to the third minus 1, 2 to the fourth minus 1. So it's going to be 2 to that power and then minus 1. Now n would be 1 to get 1/4. And there are 5 terms. So our top number here, oops, sorry about that. Our top number here would be 5. So that would be our sigma notation for that summation. Okay, example 2 says use our calculator to find this. This is, if we don't know what this symbol means, this is factorial. What that means is you multiply it by every number lower than it down to 1. So let's say, for example, I had 3 factorial. It's 3 times 2 times 1. Okay, if I had 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. Okay, we're going to use our calculator to find this. So go ahead and get your calculator out here. Struggle is real sometimes with us, as you know. There we go. All right. So to find this, what you're going to do is you're going to go second stat. That's going to be the list. And you're going to scroll over to math. And you're going to find number 5, sum. And then second stat, scroll over to operations and scroll down to where it says sequence. And you're going to type in the function here, which is 1 divided by x factorial. So factorial is math. Scroll over to probability, number 4. Our variable is x. We're going to start at 0 and we're going to end at 8. And our step is 1. And there's your answer of 2.718. Okay. We'll come back to that calculator if we need it again. Write out and compute each sum. So we're going to write these out. So we're going to, this one, we're going to put 1 through 7 into this. There's nowhere to put it, so every term is just going to be 5. 5, 5, 5. That's the third term, fourth term, fifth term, sixth term, and seventh term. Add that all up, we get 35. Second one. If you put in 3, we would get 9 back. If we put 4 in, we would get 11. Put 5 in, we would get 13. Put 6 in, we would get 15. Add that up, we would get 48. Last one, if we put 0 in, we get negative 1 and 0, which is 1, times 2 to the 1, which is 2. So it's 1 times 2. Put 1 in, we get negative 1 to the 2 times 2 to the second. If we put 2 in, we would get 1 times 2 to the third. Put 3 in, we would get that. Put 4 in, we would get this. And 5 in to get that. Okay, so we would get 2 minus 4 plus 8 minus 16 plus 32 minus 64. That's 42 minus 84, which is negative 42. Okay, at this point, you should pause this video and try the practice problems on the next couple of slides. When you're done, you can check your answers. And you can always check on Schoology as well. Pause the video now to try. Okay, here's the answers to 1A and B. And 2A, B, and C. And 3, A and B. You can pause this video as much as you need to on those to keep checking. All right, but that's it for today. Thank you as always for watching my video on just sums, sigma notation in general. See you next time.